Hey everyone, welcome back to Scale Factory. We are now diving into part 3 of our Truss Vectoring System series. In this video, we'll focus on modeling the servo mounts and finishing the entire design in Fusion 360. By the end of this session, we'll have a complete model ready for slicing and printing. If you have been following the series, you know we have come a long way. And if this is your first time here, make sure to check out the earlier parts where we modeled the truss vectoring gimbal and the servos. Let's get started and bring this design to life. Okay, in the last part we have motor, servo and our gimbal. Now we'll connect these parts first. So let's place our motor as a rigid connection. We will place the motor on our motor mount. The direction is flipped. Looks okay. Let's check it. Now it's done. The motor is in place and our joint is working. So let's place the servo. We want the servo arm on the same plane with the movement rotational plane of the motor mount. So we will rotate it around and place it. I'm choosing the reference points for all the movement and rotation. First, let's align the rotational planes. So the axis of the servo arm, turning axis of the servo arm, and turning axis of the motor mount will be parallel. For position, I already have my values for my design. You can just use them to have the same result, or you can use your own values there. So these are my values, and let's see what we have here. As you see, the plane that servo arm moves around, it will be also the plane that motor mount will turn around. There will be another servo set at the right angle, so these two axes, the whole motion will be controlled, like pitch and yaw, or you can just use them in synchronized way to control pitch and yaw with both servos at the same time. So now we are designing servo mount. Servo mount will be the piece that hold the servos in place and hold the gimbal on its place. Now we will create the surface that servo will sit on with 2 millimeters excess from the servo side. And we will extrude this place to have the wall that servo is sitting on. I think 3 millimeter, 2 or 3. 3 will work for me. Yep. As you know, almost all the servos has their cables on the bottom and going to the side. So we'll have holes on that positions too, on two sides to have being able to place servos in both directions. We have the sketch. Now we will extrude this surface that will hold the servo on its place. Let's choose them. But there is a problem. Looks like a point goes off a little bit. Let's check it. We can change the view to back. Yes, this point is a little bit off, and now it's in place. Yep, this side looks okay. So we keep going. We choose these regions and we'll have the surface that will hold servo in its place. I will use 9 millimeters, but it's up to you. Okay, it looks okay, but we will have some clearances to be able to put servo easily there. A small distance between the surface of the servo mount and the surface of the servo. So we will offset the surfaces that will touch the servo, but maybe not that bottom surface on sides, and no, the surface that have contact with the servo itself. I'm not sure about that bottom ones, but I choose them anyway. Okay, point 25 will work for it. Okay, let's check it with Servo. As you see now, we have some clearance. Okay, looks nice. Now we will make that uh, gimbal shaft longer to have that connection point between servo mount and the servo. Maybe 80 or 70, 75. Let's choose. Okay, 75 is okay. Now we can add the bearings of the servo mount that will hold the gimbal shaft, that long stick. We'll have two cylindrical bearings. 15 millimeters in diameter, I think will work for us. And it's a little bit long because we will have a connection point on this bearing. 12, yeah, 12 looks nice. Another one will be on the rear, but we will make it in a similar fashion. Again, 15 millimeters in diameter. But this one doesn't need to be that big. Maybe 5 millimeters will work for us. Okay, now the position looks okay, but we should have a hole that goes through them, so the gimbal shafts will be able to pass through it. Gimbal shaft was 7.5 millimeters, so 7.7 millimeters will be enough with clearances. We are just cutting it out, but import point not from pin, only from servo mount bodies. Looks okay. Before that, I will modify that gimbal shaft to make the assembly easier. Yep, fillets, 1 millimeter, looks great. Let's check the design. Yep, for now everything looks it's in place. Now we will connect the servo mount and that bearings. Let's hide everything. We'll design the sketch and extrude it to have that connection. Okay, I want center points. Yep, that blue region is done. We can extrude it now. It should be 1.75 because of that offset process. It was a little bit smaller than 2 millimeters. Looks okay. Let's check it from that side. We'll come to this point later maybe. There should be that line there. The same process for front bearing. We can adjust tangency later. Let's just put it in place. Yep. Okay. Now it's done. Actually, for this, we can use another tool. Let me show you. In that sketch palette, there's an option, slice. So it's just slicing the geometry on that sketch plane. It becomes way easier. Any point will be okay. Let's extrude this region in the same fashion. It was 1.75 millimeters. Yep, looks okay. Let's check around to see if there's any fault line, but before that I think we should add another bracket that looking forward for that forward bearing to increase its strength. I am designing the profile. It's a really easy triangular profile will be there. The region is ready. We can extrude it. Not cut, but join. Looks fine. Let's check around if there's another problem. Actually, I think we have some. That small surface. We'll check it later. Let's check it from other angles. Yep, looks like we just forget to offset the rear one. Let's check the distance, and if we check X positions, it's 0.25 millimeters, our offset distance. So it means we just forgot to offset the rear bearing, rear wall. We can offset it now. Not from create, I think modify, offset. Oops, a little bit bigger. 0.25. Let's check it. Okay, it's done. Another problem. that small surface. Probably on sketch there is a problem. We make two lines instead of one. Let's check the sketch. Yep. We can edit that sketch. Making that two lines collinear will just solve the problem. Let's use it under constraints. See, collinear. Oops, we made a mistake. We should choose the one that we want. The first one should be the reference, but it's not a problem. Yep, that small volume there, body there, created. Again, we can just adjust the sketch to change the profile. Something like that. Let's see. Looks fine. Now we will add that hole, and with the screw we will be able to fix the gimbal shafts and the servo mounts. But before that, I think we have some problems. Yep, there are two bodies, but there should be one. Let's combine this one and this one, join, and this wall is gone. Yep, it should be like that. We can create a sketch. The position is not that important, but we will have a hole there that pass through both the servo mount component and gimbal component. So we'll put a metric 3 screw there. That's why I'm using some like 3.2 millimeters diameter. Let's find that circle. Where is it? Okay. We'll extrude it, but both sides symmetrical will work for us, I think. Yep. And objects to cut, we make gimbal visible. Okay, both pin and servo mounts. And now let's check it. The hole is there, passing through two components. And now we can continue our design. We'll create another construction plane. This time it will be our symmetry plane. So minus 45. Yep, that's what we want. And we will mirror these faces of the servo mount. Okay, choose them properly. Looks like we choose all the required surfaces. Let's see. Looks okay. Actually, I'm always afraid of having some error while using mirror, but this time it worked. Looks like the servo mount design is done. Actually, I'm checking if we have any problems. Now we'll create that arms of the motor mount that's aligned with servo arms. So we'll be able to connect them, and movement of the servo arm will be transferred to motor mounts. Let's have some, I I don't want that orientation. We can change it. Yep, it's easier like that. First, I will have some reference lines actually. Okay, these arms will connect the lower part of the motor mount. As you remember that two pieces are separable. A hole there will work for us, I think. Okay, and some spare holes. Maybe we'll use them later for other designs. Let's find. Oh, it's too much. Maybe a little more. No, actually, yep, that one is great. Let's keep it. First holes, then the mount. It's again completely up to you, but I want something simple. This point is important because the lower part and upper part of the motor mount, the socket is separable. Maybe 1.5. Yep, it's better actually. 2 was a little bit bigger than we need. Fill it to the surfaces, the lines there to make the profile better. I will delete this one. And this one too. Oops, an extra line here. We can continue that fillet process. Another one here, and the last one. Okay, looks great. Okay, this one too. And now we'll delete it and connect the last border. Yep, it's blue, it's done. But if we extrude it like that, there are small gaps because it's over a cylindrical body. I will just make that points a little bit into the surface. So when we extrude to the sides, it won't go out from that cylindrical body. Let's extrude it. Symmetrical. Maybe 2 millimeters in total will be okay. So 1 millimeter to both sides. Looks okay. Yep, nothing is off. Okay. Looks fine. Actually, I think I know we didn't we choose join? Okay, now it worked. Probably we just create this new body. I forgot to change it, but now it's fixed. Yep, it was new body. Circular pattern instead of mirror will work for this design because it's radially placed in a pattern but it's not full, it's partial. And 90 degree minus or plus, let's try plus 90. Nope, not this one. So minus 90. Yep, it should be like that. Okay, looks nice. Let's mirror the servo too to have the complete design. It's the servo. We want to mirror again the same line. Yep, now our design is completed. From there, the parts that we will add will be the servo rods, but you don't need to 3D print them actually. It's way better to use some steel push rods for it. So that's it. Our design is done. That wraps up the part 3 of our truss vectoring system series. Our design is now complete and ready for the next stage. In the next video, we'll take this model to the slicer, print the parts on the Bambula P1S, and assemble the system with servos and a motor. And of course, we'll test it to see how it performs. If you enjoyed this series so far, don't forget to hit that like button, subscribe to Scale Factory, and turn on notifications so you don't miss the exciting conclusion. As always, thank you for watching, and I'll see you in the next video.